All right. At the request of number 2.3, we have a video to help you select the derivative procedures. If you're watching this video in 2024, you have a big homework that you're working on. I am going to do 4 of these problems just to demonstrate. Now, let's do a very basic example to start. Y equals x squared sine x. Now, I call this a basic example because, very clearly, x squared times sine x. If we draw a line like that, we can see that this is a product. Don't forget a product is a multiplication. In a multiplication, this is a basic product rule problem. So, we need to derive each part and then mix and match them correctly. So here I've got 2x. Derivative of sine x is cosine x. Right? Very, very easy, very peaceful, very demure. Now we mix and match. dy dx equals x squared cosine x plus 2x sine x. Easy, right? A little bit of mix and match. Let's spice it up a little bit. And I'm going to do, let me just put this up over there. Let's consider y equals x squared sine 3x. I'm going to start this the same way because I see a product. Now, when you've got the chain rule mixed in, you just got to be a little bit more hip and hopping. Obviously, 2x, still very easy, very peaceful, very demure. But now this sine x, and a little bit weird. I'm just going to come over here to the side of my paper. And I'm going to be like, oh, y equals sine x. If I wanted to derive that, I'm going to say, all right, well, this looks a lot like a chain rule because I have an inner and an outer function. My outer function is sine x. So my dy dx, in this case, again, this is all very separate, very demure. Cosine of 3x, right? Because I'm deriving the outer function, and listen when I say that, and just plug in this bad boy right in. Meow, I have to derive the 3x, I get a 3. So cosine 3x times 3, my chain rule says. I'm just going to plop this, right? Because what did I want to put down here? I wanted to put the derivative of sine 3x. That is going to be cosine 3x, 3. And meow, and just plug that bad boy in. Finally, my circle dancer, I'm just going to dy dx. Gotta make sure your x's and y's are distinct. It might be one of the worst dy dx I've ever done. Who cares? And I'm just going to do 3x squared cosine 3x. All these are being multiplied together, so I can put them in any order. Plus 2x sine 3x. Let's put a little line there just so it's explicitly clear. Let's do a homework problem just so that this is a little easier. Very demure, very meaningful. Y equals sine 2x 3x squared minus x. Again, this is multiplication. Very meaningful, very demure. I'm going to draw that line because, again, I've got that product. And right away, if I'm setting up my box, just, number 4 really likes the, this organizational scheme. So I'm going to keep up with it. 3x squared, this is just power rule, right? 6x minus 1. And again, sine 2x. So I know that that's not a one-stepper. That's not easy to identify. That's not just like one that I can pop out like the power rule. I'm just going to come over here. And I'm going to derive it separately. I'm going to derive that expression separately. Sine 2x, dy dx, just like I did before. Cosine 2x times 2. This 2 comes from the derivative of the 2x. Now I'm just going to pop that in here. 2 cosine 2x. But notice how I'm splitting off. Once I write this in here, I'm back in my box method. I'm ready to mix and match. I'm ready to dance. I'm going to wrap that in parentheses just so I don't hurt myself. When in doubt, parentheses. And pinky out. 6x minus 1 sine 2x plus 2 cosine 2x. Why am I always running out of room? Times 3x squared minus x. Right? We mix and we match. We go up and down. Product rule. That's a homework problem. I think that's number 2. How ironic. Let's look at, this. I want to embrace this same partitioning strategy, partitioning being the separating and organizing strategy. I want to impose that on a chain and quotient rule problem. So let's look at number 7 from the homework. Y equals x squared over the square root of 4x plus 1. Got a big old fraction. So the very first thing I'm going to do is just say, all right, I know I'm going to use the quotient rule here. But I also see a square root. And the reason I chose this problem is so that I can yell at you all and I can say, before I do any calculus at all, before I even think about doing a dy dx, I'm going to rewrite that square root as a 1/2 power. That's a mess. All right. Now, let's, I'm always running out of room. Golly. Let me do this. God, I love technology. And now again, I'm just going to impose my rules. I'm going to derive these separately, and then I'm going to put all the chunks together. X squared just becomes 2x. But the derivative of 4x plus 1 all to the 1/2 power, that's a chain rule. So 4x plus 1 to the 1/2. My inner function is the 4x plus 1. My outer function is the 1/2. So the 1/2 is going to come down. This is going to be negative 1/2. 4x plus 1. Right? Because the inside just plops right down. And then off to the side, I derive that. So I get a 4. Now I've got 1, 2, 3, 4 pieces. Let's start throwing together my answer. Where do I have space? Yeah, I can still see everything. Quotient rule. I'm going to have a big old fraction. I'm just going to take the denominator, wrap it up. I'm not even going to change it. I'm not simplifying. I am going through life. All I did there is I took the denominator, put it there. Now I do need to be mindful of order. I'm going to take the derivative of the top, which is the 2x, and I'm going to multiply that by my denominator. 4x plus 1. Wrap that in parentheses, because when in doubt, I wrap in parentheses. Now subtract my x squared times the derivative of my denominator, which is this mess, and I can already tell I'm going to run out of room on this piece of paper. God, I suck. All right. And I'm just going to copy and paste. I'm not even going to simplify. If I wanted to simplify, I could multiply that 4 and 1/2 and get a 2. But, we're fast and loose today. 4x plus 1 to the negative 1/2 multiplied by 4. All right. And just to make sure I'm labeled, that's my dy dx equals all that. So that's the chain and quotient rule. It's all about that partitioning and saying, it's all about that sorting and saying, what am I deriving in this moment? Let's plow ahead. Oh, the chain rule twice. Let's look at 14. No, let's not look at 14. Let's look at 15. Y equals the natural log. And I'm going to be color-coded right now because everybody loves colors. So actually, how about I redo this? use yellow. No, not yellow. Y equals just a, whatever it is. And I'm going to be able to do this all at once. dy dx equals. Lots of colors, very exciting, very cool, very demure. Did I say I was doing 15? Yes, I did. I'm choosing 15 because there's very clearly the 3 layers with all the parentheses. So my natural log of x, that's going to be my purple. It's going to be on the all the way outside. Sine, I use orange, oh whatever. The children will be fine. And blue, let's go with blue. 3x squared. All right, so I've got 3 distinct layers. And watch what I do here. The natural log of ln of something is 1 over something, all right? So 1 over, and I'm just gonna take this whole inside and rewrite it. Sine, with the correct colors, sine of 3x squared. And now over here, I need to put the derivative of sine of 3x squared. Well, the derivative of sine of 3x squared, my outermost function is now sine. So cosine of, oh, well, I can't touch 3x squared yet. It's not its turn, right? That's that innermost layer, 3x squared. Now I've got another layer. So I'm going to pop a 6x out there. And yes, I could simplify this. But I don't really feel, I don't feel the need to. It is a little ugly. Let me just, really quickly, this is cosine of 3x squared. You don't need to do this. I'm a crazy person, times 6x. This is 6x cotangent of 3x squared. Just because it's so nice and small and neat, very peaceful, very mindful, very demure. All right, that's that triple chain rule. The next one's going to be a little messier. Number 16. Y equals x squared sine of x over x squared plus 1. Right away, the first thing I hope you notice is that this is a quotient, so I'm going to need the quotient rule. I'm going to start my big old fraction, dy dx, x squared plus 1 squared. Very easy, very, very demure. Very exciting. I'm also going to do this. I'm going to put x squared plus 1 in parentheses in the front of my numerator and x squared sine x in parentheses there. Because I know that in this spot eventually is going to be the derivative of my numerator, and this spot eventually is going to be the derivative of my denominator. Now let's just consider those separately. The derivative of x squared plus 1 is just 2x, right? X squared becomes 2x, 1 goes away. So I'm just gonna pop that up there. 2x, very easy, very nice, very demure. And again, I'm just taking a break, breathe, look at it. What are the different chunks that I have? I have my denominator, my derivative of my denominator, my numerator, my denominator again, right? I'm just following a formula. Now, I'm gonna run out of room again because I suck. The derivative of x squared with regards to x, times sine x. That's just a product rule, right? I can, divide that up. We actually did, I think we did that exact problem earlier. 2x sine x plus x squared cosine x. That's the derivative of my numerator. That's going right there. 2x sine x plus x. Oh my gosh, you know what? I'm just going to rewrite the whole darn thing. dy dx equals that monstrosity, sine x plus x squared cosine x. Wrap that all in parentheses. What's my denominator? X squared plus 1. Minus, parentheses. Slap my numerator in there. X squared sine x. And then the derivative of my denominator, 2x. All over my denominator squared, x plus 1 squared. All right. Lots going on. Lots of derivatives. There's different chunks of this video. If I were a better YouTube, I would, put in bookmarks. Hope this helps. Let me know if there are questions that I can answer. Have a magnificent day.